Okay, in this video, we're going to try to translate real-life situations, not into linear equations, but into linear inequalities, which means we're going to be using, obviously, the inequality signs. Now, I just want to do a quick recap. Remember that when we translated real-life situations into math and vice versa, we used equal signs, but we also said that a good rule to follow is that each sentence was an equation, right? So if each sentence is an equation, we could also use that same rule for saying that each sentence might also be an inequality, okay? Because again, the structure of this language, math, is very similar to the structure of English or Spanish, where you have sentences. An equation is a sentence in math, okay? An inequality is a sentence in math. Now, the other thing that I like to do is that every time I translate something, I usually want to have one or two variables, okay? Use one or two variables when you are translating. Now, the reason we do that is because normally in math, the power of mathematics is that you're comparing one thing to another thing, right? So one variable to another variable, which is why graphing is so important, right? Because normally we have like an X and a Y, two things that we compare one another, and then we see how they change in relationship as we draw a line, okay? So these are the two things that I want you to keep in mind when we look at this top thing. Okay, so let's get started. We said that Tayden has 5 times as much money as Jack. How would I translate that? Let me just go ahead and outline that. If we keep to that each sentence is an inequality or an equation, right? This might be one equation for us. Let's take a look. Translate it right across. Tayden, T, has, which we know is an equal, 5 times as much money as Jack. So 5J. T is equal to 5J, and that would make some sense. If Tayden has $5, that means that Jack would have 1, right? If Tayden has $10, that means that Jack would have 2, etc., etc. So what we've done here is we just translated our first equation. Now, it wasn't an inequality, but again, don't worry about that. Sometimes it's a combination of inequalities and equations. Let's look at the second line. If Tayden gives $5 to Jack, so again, translate. If Tayden gives 5, that means he's subtracting 8 from his stash, right, to Jack, then Jack will have more than Tayden. So that means that he will have less than Jack, who has an extra 8 now. Okay? Now, let's see if we can get this into something a little bit more familiar, right? Let's get the J's and the numbers, the J's, the T's, that sort of thing, onto one side or the other. And also, I'm going to do something a little bit different over here. I'm going to call the T Y. Right? So let me just go over here. Wherever we see T, we're going to pretend it's a Y. Wherever we see X, we're going to pretend it's a J. Now, why am I doing that? Because if I do that, I can translate these into something a little bit more familiar, right? I can say that T, or Y, is equal to 5 times X. Oh, that looks easy to graph, doesn't it? Let's go down here. T, again, Y, minus 8 is less than X plus 8. And if I move the 8 over here, I get Y is less than X plus 16. Now, I did that because I wanted you to see these two inequalities and equations. That makes this easier to actually graph, doesn't it? Now, we're in the first quadrant only. Now, why are we in the first quadrant only? Because we're in reality, right? These are real things. This is just money. So we can't have negative money. So we're not going to use this quadrant, or this quadrant. So I'm just going to pretend we're all in the first quadrant here, okay? And let's just go ahead and graph these two. Y is equal to 5x. So, and I just say plus 0. So if we got 0, that means my slope is up 5 over 1. Let's go with 1, 2, 3, 4, 5 over 1. Okay, so there's another point. 1, 2, 3, 4, 5 over 1 again. So it would be right about there. And I'm just going to graph that. Let me just get my straight edge. And let's go ahead and graph this. It basically is y is equal to 5x. Now if I did that carefully enough, let me just do another set here and I'll show you why. 1, 2, 3, 4, 5. And that would be the 1. That would be the 2. This would be 3. Let's see if that makes some sense. If Jack has $1, X is 1, that means Tayden would have 5. Sure enough, that's it. Jack has $2 times 5, Tayden would have 10. Again, that's just it. If Jack has $3, Tayden would have 15. Yep, that actually works. So this is probably a correct line, right? No shading because it's an equal sign. Now let's try this one. Y is less than, but not equal to, x plus 16. That means that I have an intercept at 16, so that'd be 16, 17, 18, 19, 20. So there's that. My slope is 1. That means I go up 1 over 1, up 1 over 1. Let's go ahead and graph that line. There we go. And again, I would be shading downward, right? Because if I put in a test point at 0, 0, 0 is less than 16. So I'm shading in this direction. And I'm only going to the y-axis, right? Because I'm in the first quadrant. Basically, any number that would be in here would work for both of these equations. Let's see if that's true. Let's pretend that Jack has $1.50. How much money then would Tayden have? All right, so I'd say Tayden is equal to 5 times J. Let's pretend that Jack has $1.50. That means that Tayden would have $7.50. It should be in here. Let's see if that works. Tayden, $7.50 plus 16. That means that he would actually have $23.50 at the absolute most, but probably a little bit less. So if that's true, did I do that right? Did I add that up right? Times it by 5. Yeah, that works. Okay. So again, what are the things to take care of here? Assume each sentence is an equation or an inequality, and then make sure that you use 2 variables. And if it's a real life situation, make sure you put it in the first quadrant. All right, hope that was helpful to you.